Bone formation, also known as osteogenesis or ossification, is the process by which bone tissue replaces embryonic connective tissue to form the skeleton. From childhood to early adulthood, ossification lengthens and thickens bone. In addition, the process of ossification is used throughout life to remodel bones. There are two methods of prenatal bone formation. During intramembranous ossification, bone is generated on or within fibrous connective tissue membranes. As the process begins, mesenchymal cells differentiate into osteoblasts in regions called ossification centers. The osteoblasts secrete osteoid or uncalcified bone matrix. Over a few days, osteoblasts become osteocytes, and calcium and other mineral salts are laid down, hardening the matrix. The bone matrix develops thin columns of bone called trabeculae, which fuse to form spongy bone. Blood and lymphatic vessels grow into the surfaces of the newly formed bone and develop red bone marrow. Outside of the bone, a dense layer of connective tissue called the periosteum forms. Most outer layers of spongy bone are eventually replaced by compact bone, but the center remains spongy. Intramembranous ossification also occurs with skull bones in childhood. At birth, skull bones are separated by fontanelles, or soft spots, and sutures, immovable joints made of fibrous tissue. Fontanelles in the fetal skull allow for easier passage through the birth canal and rapid brain development. Up until adolescence, the fontanelles slowly ossify into sutures, providing the brain with greater protection. Endochondral ossification, the replacement of cartilage by bone, occurs in most bones of the skeleton. The process begins when embryonic mesenchyme condenses, forming the cartilage model, the shape of the future bone. The model grows within the fetus. Lengthwise growth is attained via interstitial growth. Width is attained via appositional growth. A nutrient artery penetrates the perichondrium, increasing nutrient availability to the cells. Osteogenic cells are stimulated to differentiate into osteoblasts. These cells secrete matrix beneath the perichondrium that forms a thin shell of compact bone known as the bone collar. As the perichondrium begins to form bone, it is now called the periosteum. The bone collar reduces diffusion to the cartilage inside the model, depriving it of nutrients. Capillaries grow into the disintegrating cartilage, delivering osteoblasts. The new growth forms a primary ossification center, an area where bone tissue will replace most of the cartilage. Osteoblasts deposit bone matrix, building spongy bone trabeculae. The growing model is gradually remodeled. The cavity fills with capillaries and red bone marrow. Ossification proceeds, forming the main portion of a bone, known as the diaphysis. Around the time of birth, blood vessels enter the epiphyses, the ends of a bone, forming secondary ossification centers. Secondary ossification differs in that no medullary cavity forms, and ossification proceeds outward. As a result, the interior of the epiphysis remains spongy. Secondary ossification leaves a thin layer of hyaline cartilage covering the epiphyses. This is known as articular cartilage, and it reduces the friction and shock in bone joints. The change to the epiphysis also forms the epiphyseal plate, a layer of hyaline cartilage that enables the diaphysis to grow in length.